Oops, I started more drama, this time around image formats. The reason I started this drama is because I defend webp. If you've never seen a webp file before, I don't know if you're actually online, but in case you somehow haven't, it's a new image file format that Google introduced long enough ago I shouldn't be calling it new anymore, honestly. It was made with the goal of doing a few things, making images on the web smaller, higher quality, and allowing for transparency in places where you couldn't before. Because before webp, you basically had two options. The first was PNG, which was lossless. Whatever you put in, you get out. And with a PNG, you could have transparency. So you can have pixels that aren't actually there. So you can put an image on the bottom and have it overlaid and stuff like that. Transparency is really important, and PNG supporting alpha channels was huge. Your other option was JPEG, which can be compressed massively. So it's not going to be the exact same image that you exported from your program, but it can be 10 plus times smaller, but it also doesn't support transparency. So there's a balance here. PNGs are really good quality and allow for transparency, but they're massive. Or JPEG, which doesn't allow for those things, but is much, much smaller. WebP was a fantastic solution because it fit right in the middle, but people hate it because it doesn't work in all of the places that they want it to. When they drag and drop it into Word, it doesn't show up properly. If they try to send it as an email attachment, it is a file instead of an image. These types of things are real complaints and they make a lot of sense, but the alternatives I've seen people propose make none. Another way to look at this video isn't so much a rant about why I love WebP. Rather, this is a rant about why I hate AV1. Yes, I'm going to come out and say it. The AVIF standard is shit. It is really, really bad. And we're going to break down why. So let's get started. Before y'all spam my goddamn comment section, yes, I've seen the 2 clicks fill up video. It's pretty good, but it misses a lot of important pieces that we need to discuss, which is why we're going to break this all down. And I'm afraid this is one of those videos where I'm going to have to make a chart. On the top, we're going to have the different image formats. We'll have JPEG, PNG. SVG is going to be weird to put in here, but I'll do my best. WebP, AVIF, which is the AV1 image format, and jpeg-xl. And there's a lot of different things we have to think about as we talk about these. So the first question, does it support lossless? PNG does, SVG does, but in a weird way. WebP, believe it or not, does. Also pretty sure AVIF does. JPEG does not, and I'm pretty sure XL does not as well. But now, for more importantly, compression. So can you compress the image? Can you make it smaller? This is going to be basically inversed, where JPEG, yes, WebP, yes, AVIF, yes, and jpeg-xl, yes. But PNG and SVG cannot be compressed in any meaningful way. JXL does do lossless, cool. I was not sure if they had a quality 100 option that actually was lossless. Good to know. Next, we have alpha, which is transparency. As we mentioned before, JPEG does not, and thankfully, basically everything else does. So that's huge. We don't have to worry about that as much anymore. All modern formats support alpha channels. But here is where we get to start being spicy, and people are going to start being mad. And that's fine. We're all mad sometimes. It's usually about things we're wrong about. So let's cover those things. The next one, greater than 90% browser support. Obviously, JPEG has this. Obviously, PNG has this. Thankfully, SVG has this. It wasn't easy to get there, but we are there today. However, WebP is there too. Can I Use is a great resource for checking these types of things. If we take a look at WebP, 96.01% of global users have a browser that supports WebP. So that's in a really good spot. Can I Use for AVIF is also very close here. If you want to use the AV1 image format, you can use that on almost every browser and it will work. So we go back here, put the check there. But here is where things start to fall apart for jpeg-xl. There was a thing that 2 clicks said in this video that is so wrong that I'm surprised it made the cut. He said that Chrome had support and they removed it. No, Chrome had experimental support under a feature flag and they never ended up shipping it. And there are reasons for that we will get to, but Chrome did not support jpeg-xl for real ever. It was never like you could go to a page and have a jpeg-xl, but at the very least, it was a feature you could enable. The thing about jpeg-xl is it is a relatively complex format, and that's the thing we need to talk about with these different image formats. How is JPEG different from jpeg-xl? What makes this XL? The big difference with jpeg-xl is that it is a different compression method, and the different compression method is more expensive CPU-wise to work with. So if you load a picture that's a PNG or a JPEG, you basically get to go line by line in that picture and rasterize it to something that your device can display. With the rest of these formats, It is not that simple. The actual process of taking the data from the file, turning that into actual pixel data, and then rendering the pixels on your screen is significantly more complex. SVGs, for example, are a vector graphic. So it's not actually saying these pixels are the ones to light up. An SVG is saying, here are the lines, and here's what color they are, and here are the shapes, and here's what color they are. And you have to take that data. It's almost like a description of what goes where, and then your computer has to parse that and turn it into the right thing. If you were to think of this almost like a cookbook, the JPEG tells you exactly what to put where and when. The PNG is even more specific. And the SVG is like, fill this with roughly this amount, pour it there. It's telling you like what to put where these are giving you like pre-cut portions for the exact things that you want to cook. So it's significantly more work with the SVG, but since it's a minimal set of instructions, SVGs can be much smaller if your thing can be described roughly with lines and shapes. But if it's like an actual picture with details and lots of colors, SVG falls apart fast because SVG is describing the shapes of an image. It's not actually just giving you pixel data. But that also means you can scale it up and down. You'll even see that in here. I'm using a program that's largely SVG and vector based. So I can make this big or small, and the amount of like pixels changes dynamically based on how big or small it is. It always looks good, specifically because it's a vector. It's not pixels, it's data of what goes where. But that also means it takes more CPU power to process an SVG than it does a PNG, especially because PNGs and JPEGs tend to have hardware accelerated paths where your device knows how to render these things particularly really quickly. WebP is an interesting one because it is more compressed and it does take more CPU to do things. Thankfully, it's very well supported and there's even some hardware acceleration for it, but WebP does cost more CPU-wise. So it's important to note that JPEG and PNG, if you were rendering like 500 of these on a page, the page would be faster if you rendered 500 JPEGs than if you rendered 500 WebP images. But the amount of data you have to download to open the page will be way smaller with WebP than it would be with these other formats. And here's where things start to fall apart. Both the AV image format and jpeg-xl require a disproportionately large amount of CPU power to parse them, because their goal is to make it possible to render a big image with as little data as possible. And if you compress things as heavily as these compress them, the amount of power it takes to get that data and turn it into an actual image is higher. And jpeg-xl in particular is kind of weird with this. If you want to learn more about how image encoding works, to actually see how we generate images and specifically how PNGs work, I have a video I did a while back, 67 bytes, the smallest possible PNG. I loved this video. It kind of bombed, but I think it's a great reference if you want to better understand how PNGs and other image formats actually work. This is the jpeg-xl art gallery. This is images people made with jpeg-xl that effectively abuse the format. This image, which admittedly looks really nice, is only 218 bytes because jpeg-xl can compress in such absurd ways that it's unbelievable. But just think about this logically. From 218 bytes, how do you go from those bytes to this image? And the answer is with a lot of CPU power in order to turn each of one of those bytes into the right data. It's also worth noting that if you go to this link in any browser other than Safari, I'm going to use Arc, which is Chrome-based, is what I'm normally using. None of these render. Because the only browser that actually supports jpeg-xl is Safari. Even Firefox doesn't support it. It is only Safari that supports jpeg-xl right now. Power consumption of JPEG, WebP, and AVIF. I'm actually quite curious here. WebP had the lowest energy consumption, AVIF had the highest energy consumption, and JPEG was close to WebP. Very interesting. So I might have even been slightly wrong when I was talking earlier. It appears that WebP is comparable to JPEG for energy consumption, but WebP was the best. It's a very efficient format, both in terms of the size of the file, but also the amount of processing it takes to process one of those files, where AVIF and jpeg-xl tend to be a lot heavier CPU-wise. But we go back to the art because some of these are crazy. Also notice, some of these aren't rendering. This one's 34 bytes and it just straight up won't render. If I download the image, I might be able to open that in Affinity. Affinity is pretty good with image format support. So I've been pretty lucky with being able to use it for stuff like this. Cool, it works in here. But again, here's the problem with jpeg-xl. It is a weird format that allows for a lot of different hacks to make things super performant. Like this image is 2048 by 2048. That's a lot of pixels. And the file for it is only 34 bytes. That's insane. That's really cool. But you don't go from 34 bytes to an image like this that's that many pixels without doing some crazy math. And that math takes CPU power. And it's also very sensitive to the way you implement the algorithm, because if you don't get it exactly right, you're fucked. It ends up in some ways working a lot like SVG, where you're describing patterns and then they'll do their best to actually render the pattern. It's crazy. So let's make a new section here. Rex CPU, or I'll say performant CPU wise, because I want the checks to be good. So most of these are going to stay the same, but these new formats, less so. And I'll say SVG is mostly good, but it's bad enough. I'm going to put the X. I almost wish I had done this like as like ranges instead of check or not check, but you get the point. There is one more point I want to make, because right now it seems like WebP and AVIF are relatively neck and neck, but the CPU performance here is notable, but not enough to just keep using this weird format, especially when other things support it. There's a couple other things we need to talk about support for. There is, I'll say, general software support. And the harsh reality here is that the only things I can honestly say have general software support are PNGs and JPEGs. Everything else is much iffier. I would say that both SVG and WebP are like 50-50. I'm going to start marking that. I'll just make it like this yellow line of like close. So the yellow line means close, but I can't in good faith say it. And then both jpeg-xl and AVIF, no, they just don't. They're not there yet. I would love for them to be, but they are not. But there's one last piece that I think is very important for us to talk about. In this one, to 2Click's credit, he does cover a bit, but I wish it was covered more often. It's progressive loading. We've all seen this before, where it loads 25%, and as you wait for it to load, it comes in like one row at a time. That's because of how the format works. When you're loading the data, it's loading it in one, effectively a row of pixels at a time for JPEGs. JPEG versus jpeg-xl versus AVIF. Let this whole thing play phase. I want them to feel the pain of watching these load in. We're almost at that. Yep, cool. We just hit the 627 kilobyte mark, and then the whole AVIF image comes in. Sequential JPEG, still loading. The progressive one enhances as it gets more data. The thing I want you guys to note, though, is that the jpeg-xl always has the right colors, but the pixel density is off. So the magic of jpeg-xl, the thing that makes the format magical, see how blurry it is right now? They've effectively allowed in the jpeg-xl format for you to have, how do I put this? Instead of when you read chunk by chunk, it has all the pixels for the first row, and the second row, and the third row. It has the first chunk be a pixel for every part of the image. It's not the whole 10 or 100 pixel chunk. It's just one pixel at a time from each section. So if you have like, imagine we have grids of 10 pixels, like 10 by 10 chunks across the image. The jpeg-xl format will let you load one pixel from each chunk initially, then load 4 pixels from each chunk, then load the whole chunk. And that means you can get a blurry, low-res version of the image immediately. And then it scales up the resolution as it continues to load. That's awesome. That's a really cool thing the format allows, but it's also significantly more complex CPU-wise, so it comes at a cost. And yes, I know my face is covering, but it's covering the top part, which doesn't matter. Pay attention to the bottom part. Look at how this starts, where the progressive JPEG comes in black and white initially. This snaps in, and it looks like it just stays there, but see how blurry this picture is right now? It gets less blurry as we go. And that's the magic of the new jpeg-xl format, is how it allows for that. Is there a version of this with WebP? Ah, here we go. Wait, no, this is generations. This is regenerating the image to see how lossy it gets by the end. Like, how much data do we lose if we keep re-encoding the image over and over? Which is also of note. If you generate a WebP from a WebP and you do that over and over and over again, you lose data, as you do with JPEG. jpeg-xl and AVIF, you'll still lose data. Like, you'll see the color goes to shit on them, but you lose a lot less because the compression is better. Yeah, jpeg-xl offers really cool things here. Like the fact that with jpeg-xl, you can specify which parts of the image to load. Also see that this is on the Google blog. Google doesn't have some evil like conspiracy to kill jpeg-xl, which is what a lot of people, including 2clicks, have implied. And I really want to jump on that because Google doesn't hate jpeg-xl. They're not some evil company trying to promote their proprietary format. No, all these are open formats. All of these are open standards. Google's goal here is very explicit and obvious. They're trying to make it so images load better and faster on the web. But they have learned a lot about the CPU costs, as I was seeing when I was looking through the WebP stuff here. They don't support progressive or interlaced decoding in the same way JPEG and PNG do because it's likely to put too much pressure on the CPU and memory of the decoding client, as each refresh event involves a full pass through the decompression system. In the Advanced Decoding API section here, they specify that how this will affect memory usage because they've done a lot of work on that. I'm not going to sit here and pretend that Google doesn't prefer WebP, but it's not because they invented it and they want it to be successful. It's because of the CPU performance. They care a lot about the performance of devices that aren't really new, because believe it or not, a lot of Android phones, in fact, the majority of Android phones, are running shit processors from 6 years ago. So if we move to these new formats that are specifically meant to benefit people who live in places where they're using 3G and they're on a crappy old phone, if the goal is to make it so they load less data, we should do it in a way where their CPU doesn't get destroyed as well. And if we were to move to jpeg-xl, the amount of additional performance hit those devices would take just to decode the images is massive enough that it would not work out. The people who benefit from having to send less data also have shit CPUs. So we have to find a delicate balance here. We need a way to send users images that don't require as much bandwidth without them having to use a bunch of CPU to make up for the difference. And WebP was invented to be this balance. When you look through guides about WebP, when you look at Google's information about WebP, you'll see the word CPU come up a ton because they care so much about the performance. As they call out here, they offer incremental decoding because it saves memory, CPU, and repaint efforts on the client. The word CPU appears on this one random page 5 times because they talk about it a lot. They care. WebP takes less time to decode in the presence of seeking. In blink, scrolling or changing tabs can hide and show images, which results in animations being paused and then skipped forward to a different point. Excessive CPU usage that results in animations dropping frames can also require the decoder to seek forward in the animation. In these scenarios, animated WebP takes 0.57x as much total decode time as GIF, resulting in less jank during scrolling and faster recovery for CPU utilization spikes. That's huge. A lot of the effort here is specifically to make performance as good as possible. The important thing to know about AVIF is that it is based on the video format. And if you know anything about video formats, you should probably know that their goal is to save on color space as much as possible. Because if you have individual frames, like if you have a 30 frame per second video and you're encoding every color on every single frame, the amount of data that you're going to have to deal with there is just unbelievable. It's impossible to work with. And the goal of the AV1 standard is to make it so you can encode video really, really efficiently. But it cares more about the encoding between frames than it cares about saving data in the first frame. In the AV image format that we're talking about here, AVIF, it doesn't get a lot of the benefits of compression per frame because the focus of AV1 is having each frame progressively save more and more data. So you end up with files that tend to be much bigger and color spaces that tend to be much worse. So you don't get as good of an image out of this, and it also tends to be bigger. It's a lot closer to WebP than jpeg-xl in terms of the power of the format, but it's also way worse supported. So if I go back to my diagram here, the AVIF and jpeg-xl are just straight up not supported by basically anything. Like no software supports these. Just because jpeg-xl sounds like JPEG doesn't mean it magically works in shit. It doesn't work in browsers. It doesn't work CPU-wise because it's just so much like lifting to do. And the general software support is garbage. There is very little software that can parse a JPeg-XL, and there's a decent bit that can parse a WebP. We're just not there with that format, and I don't know if we ever will be, because if you were to switch your website to JPeg-XL, it would load slower because of the CPU costs. This is from web.dev because Google is now pushing AVIF, which is surprising to me because I know it's not the most ideal format, but I'm curious what they have to say. AVIF is an open royalty-free image format. It's based on the AV1 video codec standardized by the Alliance for Open Media. Yep, cool. Chrome alone, AVIF usage has grown to approximately 1% in a little over a year after Chrome added support for it. Yeah, MGX reports 60% file size savings compared to JPEG and 35% compared to WebP. So it is more efficient in terms of the space than WebP. But that's not a huge jump, especially coming from the 60 from JPEG. Also, when you consider how much bigger a PNG is than a JPEG, that is a big number, but the 35% from WebP is not that big a deal. These file size savings lead to significant storage savings, but also help pages load faster, yielding faster LCPs, etc. Having smaller images makes the web feel much better. That all lines up. So this image is how big are each of the files compared to an old school turbo JPEG. Mozilla's customization for JPEG gets a lot smaller, and WebP is similar. jpeg-xl, decent bit smaller, but not that much smaller. And then AVIF is way smaller. It's also important to know that if there was a PNG here, it'd probably be 2x the size, if not more, depending on the image, of course. This is about quality. Notice this is the file size percentage of turbo JPEG. So this is for similar quality, an AVIF file is a bit over 25%, closer to like 35% of a turbo JPEG image. That's what this says. Very useful. The chart below here, this is how much effort it takes to encode a given image. And this is where WebP kind of sucks for best quality, but there's a reason for that, because WebP at best quality is a lossless encoding. This is a very interesting chart. Higher is better. This is the number of megapixels that can be rendered per second on whatever their test machine was. Since the best quality for AVIF and jpeg-xl isn't lossless, but it's as close as it can get, it has to put a lot more effort into making each pixel or megapixel as close to correct as possible. Since WebP can actually be lossless, because WebP has a lossless option, it can just spit out the lossless version and generate much faster. The jpeg-xl version's apparently lossless, but their encoding methods are so insane with jpeg-xl that it takes a lot more work to encode it. And if you compare that to the fast version of any of these, or just JPEG in general, it tends to be much faster. But this encoding cost doesn't matter too much, because this cost isn't how much the user has to wait to see the image. This is when we go from a PNG to a compressed image on our servers, how much power does it take to do that? And thankfully, because of the effort that was put in on a lot of these encoders, this isn't too bad. So if you want this to go faster, you could just spin up a faster server. The thing that matters more is the decoding cost, because that's what the user feels. I can't just buy the user a faster processor or a faster internet connection, but I can increase the power of my server to make these images more efficiently. There's a great article by Jake Archibald here that he released when AVIF became a real standard, comparing and contrasting it with other solutions. Here we have a JPEG that's 81 kilobytes. We have a lossless WebP, which is more than twice as much, but I don't know how much this will come through in the video. There's a massive difference here where the WebP version is just much sharper and clearer. The JPEG one is immediately real blocky and foggy, like instantaneously so. The lossy WebP looks very similar to the JPEG. Actually looks a little bit better. It's less blurry and noisy, but it still has that like blur to it. But it's 26 kilobytes. It's almost a fourth the size of the JPEG, and it looks better. At these really small sizes, WebP is phenomenal. And the AVIF looks very, very similar to the WebP. And yes, it is half the size, but they're so close when you're talking about numbers that small that it doesn't matter that much. The cut to 1/4 the size of JPEG is great. Another half cut is much less big a deal. And I know it's like, there's a better option. Why don't we click it? Why don't we use that? It's better because it's newer. It has less support. It doesn't have some of the benefits of WebP. Here's another fun example. This one's fun because they're all said to be the same image size. So if we look at the JPEG, which is 12.3 kilobytes, everything's a blurry mess, especially where there's multiple colors. See like the red block and then the yellow block? It's doing its best to minimize how much color data it has to keep track of. If we switch this to WebP, the colors get significantly better immediately. The JPEG has all the weird blockiness with the colors. The WebP, way more even coloring. The shadowing's a little bit blocky still, but everything else looks so much better. And even then, the shadows look way better than they do in the JPEG, where it's like a line and like bad jaggedy edges. I hope this comes through in the video, but man, the difference here is absurd. Now we look at AVIF. It is, again, a pretty solid sharpness win. I'm actually surprised the gap between the WebP and the AVIF here is as big as it is. This looks significantly better at that size target. At these sizes, JPEG has done its own art, and the WebP looks blocky and messy. But that's because we targeted a specific size rather than targeting a quality level. This is the comparison. I knew I saw it. I knew I had this comparison somewhere. Yeah. But here you can also see the benefits of the JPEG progressive decoding, where it loads way faster, but it's blurrier. And you can even see how blurry it is. It starts black and white, and then the color comes in, very blocky still. The WebP slowly starts to load in, but it's full quality load in. The AVIF comes faster, but it's all at once. It pops in immediately. And the JPEG slowly increases its quality over time. Really good comparison. I've probably found this. The JPEG is still technically loading. It's blurry up until that point. The above shows a high-resolution image, 2000 by 1178, high-quality image loading at 2G speeds. The JPEG is 249 kilobytes, the WebP is 153, and the AVIF is 96. Although they're all loading at the same rate, the much larger JPEG feels faster because of how it renders in multiple passes. That's the other thing. This is why the CPU cost is so big with JPEG stuff, is it has to render each image multiple times. It renders it once in black and white, then it renders it with more of the data, and then it keeps re-rendering over and over. It's also why jpeg-xl, if you're using the progressive features, is much heavier as well. As he says here, AVIF feels better suited to smaller, quick loading images, but that still covers most images on the web. Maybe this could be solved if the format could provide a way to embed a preview version of the image. I love that idea. Blur hashes are a really cool pattern I wish was easier to use. The goal of a blur hash is to take an image and represent the image with as little data as possible in this blurry way. So if you take one of these images, like this picture here, the blur hash it spits out is this tiny little string, and then you can render this blurry version as the rest of the image loads in, which just looks much better overall. So we have the full AVIF, looks great. Half resolution, low quality, looks awful. But if we blur it, it actually looks fine. So if we start with this blurred version that's 3 kilobytes and then load the full version later, that's a good workflow, but you have to do that by hand. Adding 5 kilobytes to a big image like this seems worth it to get low quality early render. Here's what this would look like with the different formats. You get the blurry immediately. And then it gets sharp, and the WebP is still loading. This makes WebP look like shit. I get that. Fair. Whatever. Yep. But the big thing with AVIF is that the encoding is very expensive. It's especially bad in Squoosh because they're using WebAssembly, which doesn't let you use SIMD or multiple threads. Yeah. If you're trying to encode AVIF in the browser, you're kind of fucked. At an effort of 2, it takes seconds to encode. Effort 3 is significantly better, but it takes a couple of minutes. Effort 10, which is what he used for the images in this article, can take up to 10 minutes to encode a single image. That's insane. Thankfully, you can install the command line tools, which are orders of magnitude faster. Very useful. Also, I probably mentioned this earlier, Jake Archibald used to work at Google, and he helped build Squoosh, which is the image formatting tool that is used to test a lot of these new formats. As he says, the difference between WebPs and AVIFs are not that big, so it might not be worth creating an AVIF, but some of the things he saw here with the decoding progressively are actually really impressive. And you know what? I'm getting convinced too. I think AVIF is a much more logical direction, and the jpeg-xl just isn't ready. My own mind is starting to change as I read this. I know we all hate Hacker News, but this reply here was actually really good, and I wanted to use it as a reference point. jpeg-xl and AVIF have trade-offs. AVIF works extremely well at compressing images down to very small sizes with minimal losses in quality, but it loses comparatively to jpeg-xl when it comes to compression at high quality. So if you want a high-res image, jpeg-xl does that really well. Again, if we look at this image here, 2048 by 2048, and it's how many bytes was this one? 34 bytes for a 2048 by 2048 image. That's just unfathomable. 4 pixels at 34 bytes is hard to comprehend. So if you want high-res, jpeg-xl is great. If you don't care as much, AVIF is great. But also, AVIF has an upper limit on canvas size. Yeah, see, JPEG doesn't give a shit. OG JPEGs can become JPEG-XLs, which is nice and fun, but the important piece here, I really like this breakdown. WebP fills the PNG role while providing better lossless compression, specifically with the transparency and lossless while still being compressed. AVIF fills the JPEG role for most standard web content, and theoretically, jpeg-XL could be used to migrate old JPEG files and also get the benefits of jpeg-XL or AV image format without lossy compression. And also jpeg-XL can be used for very high fidelity images. This is a fun one because it's something I wanted to bring up before, didn't have a good place to. You know that shitty friend AI that everybody likes to make fun of? The weird AI pin? I'm curious if they've fixed it now because I give them a lot of shit for it. Yes, they haven't. Yes, this whole page is a single giant JPEG that isn't actually a JPEG. If I save this, here's the FF probe results. The interesting thing here, see that? PNG pipe? This picture's a PNG. They labeled it as a JPEG, but we see here as well, this is a PNG. They renamed a PNG file to .jpeg and just uploaded it like that's normal and fine. And now you're rendering this 6.6 megabyte image as most of the page. And if you have a slow internet connection, which I'll fake here with the 3G button, you'll see how miserable the site is. It's loading right now, so you're seeing the old version. So this is the actual load experience. Great website. Wonderful experience. 10 out of 10. You should definitely buy one of these pins. because the website has a 6.6 megabyte image as most of the content. I hate this. I'm not going to sit here and watch the whole thing. Hopefully you get the idea. If you don't have a gigabit internet connection, which most of the world doesn't, these giant formats don't work. But I guarantee if I just quickly made that a jpeg-xl, let's find a converter for it. Even just a standard JPEG, if they didn't use a fucking PNG, if we were willing to compromise on quality enough, would be down to significantly smaller. And if you look at the difference here, it's not notable. And the website could, instead of loading very, very slowly, it could load literally immediately. Like, the fuck. Even if we didn't want to compromise on quality, even if we bump that up, we're now down to 2 megs, 70% smaller. If we were willing to compromise any amount, even just like 80% quality, 164 kilobytes for the JPEG-XL. Even just use a normal JPEG format or like webp. We'll do webp. 101 kilobytes. Do you understand the difference here? That means the web page will take 1/60th the amount of time to load. 1/60th. That's insane. Using these gigantic lossless images is just bad for the web and bad for users. Thankfully, just to showcase that you don't even need to go all in on these things, even just a standard boring old JPEG with 90% quality here, which would be comparable to the quality levels we'd be getting from these other formats, 860 kilobytes. Tiny. I want to go back to this for a second because I do want to say one thing that makes me sad. I love the progressive decoding features that are built into JPEG-XL. The idea of not having to provide different versions of an image, one that's really low res and one that's really high res. Instead, you just fetch as much data as you need on the client to render the right resolution for that client. I can show you a low res version as the quality increases. It would be great if more of the web worked this way. But if it comes at a huge CPU cost, it's not worth it, which is why I have become relatively bearish on the adoption of JPEG-XL, because the only real benefit of it is the ability to enhance images as they load in and to get slightly better compression on massive versions of images. That is awesome, but it's not awesome enough to support yet another format. So this image here is the Battle of the Codecs. This was from Cloudinary because they care a lot about images. And this shows all the different standards and what benefits and negatives they have. JPEG-XL here clearly has the best compression regardless of your fidelity. PNG has no compression, really, and they only offer high fidelity and lossless, so that makes sense here. And you see they're rating the compression overall. They're saying WebP is half as good as JPEG here, specifically JPEG-XL. I don't think that's fair. I think WebP offers meaningful improvements over JPEG, and this is a bit of a reach. Anyways, compression for other images. WebP is better here for things that are lossy and not photographic, and also the opportunity to have things like alpha transparency is really nice too with WebP. As we go further down, the encode and decode speeds are important pieces. They're claiming JPEG-XL decodes really well. I haven't seen proof either way there. I would love for demos to make that reproducible. But as we see here, WebP decoding is very fast, but it's also not parallelizable, unlike JPEG decoding. Or is that for encoding? I think only encoding can be parallelized anyways. But yeah, they're saying JPEG-XL handles all that really well. Maximum image dimensions. This is a fun one. As I mentioned before with AVIF, very limited. You can only have images up to a certain size, which is terrifying. Once we get into color spaces and lossy versions of them, things get a bit more complex. WebP doesn't support that, which is kind of news to me, but checks out for how the format works. HEIC also doesn't, which is weird because it's Apple, so you'd think they'd be really into those types of things. But the new formats like AVIF and JPEG-XL do support it. Wide gamut HDR, I think WebP and JPEG are the only things that don't support wide gamut HDR stuff. Annoying, but makes sense. And the maximum number of channels, weird thing to include there. And now features. Here's where things get fun. Basically, everything supports animations other than JPEG and JPEG 2000. APNG is not a real format. I don't think it's fair to include that here. APNG is shit. Progressive decoding. The only things to get 4 stars here are JPEG 2000 and JPEG-XL, because those have really good decoding behaviors. Nothing else does. Alpha transparency, everything but OG JPEG. I didn't know JPEG 2000 has alpha. That's news to me. You learn more every day. Depth maps, not super important, but cool they support them. Overlays, very weird, but I guess cool. Authoring workflow suitability. Not sure what they mean by that. Generation loss resilience. That's a fun one. That's like, you know, the classic, if you save a JPEG 100 times, the format gets terrible. Do I look like I know what a JPEG is, where it's been JPEG saved over and over again? Classic. XL handles that well, at least better than other things do. but none of these handle resilience to loss particularly great. And the only thing that does the recompression is XL. Of note is that HEIC has a royalty when everything else is royalty free. You have to pay a license fee for HEIC, which is why I didn't include it in my other comparisons, because I don't think you have to pay to encode an image. I think that's stupid. But all the rest are royalty free. This is a great image breaking things down. I liked my chart more, but this is a good one. Thank you, Dark Swordsman, for dropping this one in my replies. WebP is relatively well supported. It works in almost every program that I use. It works great. But this tweet went super viral, almost 20K likes, because this format pisses people off. Because if they save an image from Google and it's a WebP, and they try to use that image in another program like Word and it doesn't function, they blame the format. But the reality is that the image format is supported by a lot of things, but its goal isn't to be saved and used in other programs. Its goal is to be loaded as fast as possible, which is why I made my tweet, which is that WebP's way smaller. It supports transparency. It works in every browser other than Internet Explorer. Internet Explorer, the browser that has 0.6% market share now, works in everything else. And it's also trivial to convert to other formats. I also dropped my hot take, and I might die on the hill that more browsers should do this. When you save one of these new image formats, it should just by default save a JPEG or a PNG. Just do the conversion on the user's device so they don't bitch about these things. And if you want to be one of those users that has things working in that way, I will link a Chrome extension. I was actually going to go build or do an iteration on this. But if you don't want to wait for me, which I totally understand, you can use the Save Image as Type Chrome extension, where you can right-click an image and choose what format it saves as. So if you do want to use an image in a format that works for everything once you've saved it, just save it as a PNG. You don't need to use WebPs just because that's what the file was originally on the internet. When you load the page, it can be a WebP, and then later on, you can grab the PNG when you actually want to save it and do something with it. That's totally fine. And I agree, once you're saving the image files, WebP can be a little annoying to work with. But when you're going to the web page in the first place, it loads significantly faster because of WebP. There was a really dumb reply here, yeah. 99% of people would not hate the thing if they never had to use it. It loaded on the page. They're using it. Most of the time you're looking at images on the web, you're not saving them. You're just using the web. But as Crapto here said, the browser is using it then, not the person. That reply, I'm not going to sit here and linger on it. I hope you guys can understand how dumb that reply is without me having to explain it to you piece by piece. Let's finish this chart up fast. JPEG has progressive loading, but kind of. It's not good progressive loading. What we're going to do here for these is we're going to do check, X, X, X. All of these don't. AVIF doesn't. And I'm going to do 2 checks for JPEG because it's the only, or jpeg-xl because it's the only one that has like really good stuff for progressive loading. Yeah. Hopefully this helps emphasize why I think the way I think about image formats and why, generally speaking, I tend to go with WebP. I think WebP has struck a really awesome compromise here, where from the amount of compression it gets, which is much better than JPEG, to the amount of CPU cost it takes to render it, it's almost none, to general software support, which is admittedly not as good as JPEG, but it's better than most things. And it supports alpha channels, and it supports animations, and it supports all these other things, basically everything other than progressive loading and decoding. WebP represents a phenomenal compromise, and that's why it is still the image format I personally choose. If you're a developer and you actually want to make your images render properly, right now my recommendation is still using something like Next Image, like the image component, and optimizing through services like Vercel, Cloudinary, or any of the other options. But make sure you're subscribed because I have some fun things coming there. I've kind of been on an image bender for like a month now, and I'm building some cool stuff. So make sure you're subbed, make sure you stay tuned because I want to make these things easier, both for developers and for users. And until next time, peace nerds.